Hi, and welcome back. So, in this video, I think we're finally going to get into some actual, I guess, chemistry instruction. The past bunch of videos have just been kind of supplemental material and maybe some good resources for you before, I guess, before we get into chemistry. But now, I guess, we're ready to kind of start talking about chemistry, and probably the best place to do that is to just define the word chemistry. And I guess maybe this isn't so much a broad definition of the word chemistry. I think the actual definition of the word chemistry is going to be more about working with chemicals and working. It's going to focus more on the chemical side of it. But essentially, I want to, I guess, say what we're going to be doing in this playlist, and the best description of what you're going to be doing in a general chemistry course is you're going to be trying to explain things that happen on an observable scale based on phenomena that happen on a very small scale. So let me write that down. We're going to try to explain macro behavior based on microscopic tendencies or behaviors. Tendencies. So pretty much what we're going to be doing is we're going to be looking at a bunch of different things and saying, like, look, why when we put hydrogen and oxygen into a balloon with each other, why doesn't it react, but then when we set a flame next to it, it reacts violently? That is an observable behavior. That is a macro behavior. And the way we're going to pretty much explain it is we're going to explain it based on microscopic tendencies. And, I guess we're going to be doing that with a lot of different things. We're going to be looking at some acids and saying, why do acids react with metals? That's a macroscopic behavior. That's something, when we put a little piece of aluminum foil into contact with hydrochloric acid, you definitely see a reaction. You see it looks like the aluminum foil gets used up, and that is an observable behavior. It's something that we can very much see. It's a macroscopic behavior, and we're going to explain that based on microscopic tendencies and based on things that we are going to observe, or that we are at least going to talk about at the microscopic level. And the level that we are really going to talk about them on is going to be the atomic level. And so that definitely raises the question of, well, what is an atom? That is really what we're going to be talking about a lot in the course. And an atom, and we know that an atom consists of more fundamental particles than just the atom. The atom isn't as small as you can possibly get in matter, but the way we're going to define an atom is it's going to be the fundamental building block for all matter. And probably you know that I guess if you I know I've mentioned this a lot, but at this point, if you haven't checked out the Khan Academy's videos on the atom, and it's the first video in the chemistry playlist, I definitely recommend checking it out, because Sal does a great job talking about the atom and sort of giving you a much better overview of the atom, probably, than I'm going to be able to do. But where the word comes from, and Sal definitely talks a lot more about this in his video, but it comes from back, I guess, in ancient Greece. Some philosophers would philosophize about saying, if I had some object and I was going to cut that object into smaller and smaller and smaller pieces, eventually I'd get to a piece where it would be impossible to break that piece apart anymore. It would be, I guess, as small as you could possibly get. It would be more or less the quantization of all matter. And that's where the idea of the atom comes from. And even if you the word atom in it's a Greek word, or I think the root of the word is Greek, and it means uncuttable. Uncuttable. So, and even, you might know now that, we have figured out ways to divide the atom, and, we're definitely going to be, in this course, talking about elements that make up the atom, and the different particles, and in some cases it's even going to be difficult to talk about them in sense of being particles. But we know that an atom consists of other material. An atom isn't as small as you can possibly get. So then I guess that raises the question, well, what is an atom? What's an atom comprised of? And the atom, for our purposes, and there are more parts to an atom, but for our purposes in this course, what we're going to be talking about are going to be the three main parts of the atom. The first one is going to be the electron. The electron. The second one is going to be the proton. And then the third one is going to be the neutron. And for what we're going to be talking about, we can say that the electron, we can think of the electron as having a -1 charge, and I'll probably, you'll see me a number of times writing. I sometimes like to write electrons as just that. I'll write an E with a minus and a circle around it to show that one electron has a -1 atomic charge. The proton, which you might see me write like this, is going to have a +1 charge, and that you can kind of tell from, positive proton, it's going to have a positive charge, and you might see me write a proton like that. And then a neutron which is going to have no charge. So these are going to be the three main elements in the atom. And now I guess that kind of brings up the question of how are all of these elements, or how they're not elements, how are all of these different parts, how do they fit together inside of this atom? What do they look like if we were able to see an atom? And essentially, what they look like, and I'll go down, I've got my, there we go. Essentially, if we were able to see an atom, and again, I'd recommend you check out the Khan Academy, because Sal does probably a better job of showing you a better drawing of an atom than I'm going to be able to do right now. But essentially, if we were going to look at an atom, and we'll call this a helium atom. But if we were going to look at an atom, essentially what it would look like is something kind of like this, where we've got this cloud, this haze, or it's, I don't even know exactly if it would look like a cloud or a haze, but at the center of this haze, we would have our nucleus. We would have our nucleus. And this nucleus, and this is in purple right here, the nucleus, the nucleus, that is going to be where the protons and the neutrons of the atom are. They're going to be in this nucleus. And then this haze, and we're saying that this is a helium atom. In a helium atom, we have got 2 electrons. We've got 2 electrons in our helium atom that we're looking at. This whole haze is going to be those 2 electrons. And we'll definitely talk more about, I guess, why there is this haze around the atom, and why we can't just say, well, there's an electron right here and there's an electron right here, or anything like that. We'll talk more about this in the future. But essentially, if we were able to view an atom, which we really can't, even reflective light is, as Sal said, it's too it's too blunt an instrument to be able to view an atom. So this is really just sort of an artist's depiction of what an atom might look like. We can't even tell where exactly these electrons are going to be. We're going to, instead of, I guess, having, and again, we'll definitely talk about this more in the future, but essentially all we can necessarily say about the electrons is that and in this depiction, as we get lighter and lighter shades of white, we have a lower probability of finding an electron at that point. And as we get to darker and darker shades of, I guess, gray and then into shades of black, we have a higher probability of finding an electron. And again, I'm not trying to confuse you with this too much based on this first video about chemistry, because we are going to learn about this in the future. We're going to learn about the Heisenberg uncertainty principle. But the important thing to realize about these electrons, so we can say that we have got this haze that is going to be these two electrons in our helium atom. The important thing to realize is that the more that we know about exactly where these electrons are, the less we know about how fast they're traveling, and the more that we know about how fast they're going, about what their velocity is, the less we can know exactly where they are. And so pretty much what you get is you don't get an exact thing where we say, oh, well, the electron exactly moves in an orbit like this around the nucleus, or the electron exactly moves like this. We don't have an exact trajectory. We don't even know, we can't even say at any given point where an electron is going to be. All we can say is this is the probability of finding an electron somewhere within this haze. And as we get closer and closer to the nucleus, and as we have a darker color on this depiction I've got, we've got a higher probability. And as we move farther and farther away, and we get lighter and lighter shades of gray, we've got a lower probability. And even that means, again, Sal does this better on his playlist, but there is some small probability of finding an electron all the way out here, even though, we're even off of the page. And there's a similar probability of finding an electron all the way out here. It's a much lower probability of finding the electron somewhere close to the nucleus, but still there's a probability of being able to find an electron out there. So anyway, and even, this is, again, it is kind of philosophically interesting, because remember, the nucleus, and I forget if I've said this yet, but the nucleus only makes up one 10,000th of the space of this entire atom. And then you might wonder, well, if this whole haze is just 2 electrons, then what is all of this extra space in there? And that's just it. This is all empty space. So I guess 9,999 10,000ths of our helium atom here is going to be empty space. And even that's not unique to helium atoms. This is really for any different type of atom. So if you look at, your desk or your computer, or your pencil that you're using to write with, most of that matter that you see there is actually going to be empty space. And even here's another interesting part of and I'll give you some more. I'll definitely give you some specific more specific numbers about how much mass is actually in the nucleus in a future video, and we'll actually maybe do some kind of simple calculations based on how much mass is in the nucleus. But for right now, it's just important to realize that this nucleus, this thing that is this area of our atom that is only 1/10,000th of the size of the entire atom based on the amount of space that these electrons take up, that this nucleus is where most of the mass So the nucleus has got most of the mass. And I'll give you some specific numbers about how much, and we'll see that it really is, it's very close to 100% of the mass of the nucleus is just going to be in this tiny little spot that's 1/10,000th the size of the entire atom. So anyway, and then, and I guess one last thing to just point out, and we said in the last video that protons have got a positive charge, and these electrons that are floating around, these have all got the negative charge. So it's important to realize also that, while these electrons are floating around, that is essentially what keeps them in this. It's not an orbit. You can't call it an orbit around the nucleus, but it's what keeps them in this orbital, which is essentially the probability function that we have of finding an electron somewhere in this haze. It's this attraction between a negatively charged electron and a positively charged proton. So anyway, I'll leave you there. I didn't really throw out any real specific numbers. I guess more what I was trying to do in this video was to just give you maybe an intuitive sense of what an atom might look like if we were going to look at it close up. So anyway, in the next video, I'll maybe try to give you some specific numbers about just how much mass is inside of our nucleus compared to the mass of our protons, or the mass of our electrons. So anyway, thanks so much for watching, and I'll see you in a future video.